Well, we always start with some sort of description of our problem domain, right? So we start, even if we ourselves want to write an application that deals with something that we're ultimately familiar with, most likely you want to take some notes, write these notes for yourself, or if you're developing a real application, you have some sort of problem description, problem requirements, and so forth, which you will analyze in terms of use cases, and then eventually you get to decide what classes you want. And in the process of analysis of that problem description and understanding of the use cases, you essentially will face all kinds of language, and it can say because of, or before or after, or the knowledge of something, right? And that would indicate different types of relationship. These are essentially the indicators, the signals, the highlights of the fact that when you will be making your decisions, you will experience this cause and effect, that something depends on something becomes a precondition to something else, right? Temporal relationships, for instance, before, after, or exact time, may indicate that the objects must be constructed at the same time or destroyed at the same time, or maybe one object needs to be constructed before another one, so that the first object is already in existence before the second object is constructed, right? So kind of temporal indicators may be present in the initial original language of the description. Association between objects is like something knows about something else. Like, for instance, driver license knows about a specific person, the existence of a specific person, or driver license has a reference to the picture of that person, right? Any kind of knowledge like this suggests that there is an association between the two separate objects, perhaps in memory. Abstractions, we say that abstraction is heavily overused word in programming, because really, especially when you think about the object-oriented aspect of software, everything is abstracted. If you think about driver license and the owner of that or holder of that driver license, it's all abstraction, right? Because you don't have a physical presence of that, piece of plastic with magnetic strip or something. You want to approximate it, you want to abstract it. It's not precise, but you only capture the elements, the attributes that would be important to what you do, right? So anyway, so again, abstractions are essentially the kind of attributes that you choose to store with your object, and then what are the ranges of these values? What are values that are acceptable and good, and what would be considered incorrect or improper and unacceptable, and otherwise should be guarded against, right? So these are type of abstractions within existing classes. Aggregation, when we talk about parts. Composition, same thing. The fact that something consists of something else suggests that like whole part type of relationship. And inheritance, of course, is that when we deal with different kinds of things, right? When you discover that there is something common about your objects, but there's also specific types, like I just had that elevator versus cargo elevator, right? Which are two different types of elevators. That would be different types, different kinds would be an indicator of an inheritance. Right. So I always look at these things, and it's good to refresh your memory on these types of things before you begin to analyze a new problem specification, a new set of requirements, essentially, as you start working on on a new project, and it's just like interesting set of things that you should be aware of. Yes.
Dependency.
So the question is dependency a type of relationship, or what is the question exactly?
It's the same thing as a cause and effect.
Cause and effect. I would say dependency is definitely falling into this category. Yes, I think that dependency is the best description of this type of relationship. Yes, dependency would be an indicator of cause and effect. But also dependency, since we touched on dependency, dependency is not sort of like an intentional relationship. I can tell you that, say, I have just for an example. So say I want to have an application that deals with, say, stock market, and you have like bonds, you have security type of objects in your system, right? And you have some sort of, let me see, maybe you want to run some predictions on the values of your financial instruments, such as bonds and securities. And what you want to do is maybe you want to build some sort of like in your internal rating engine. All right. The rating engine, which basically internally assigns ratings to bonds and securities, and like you have rating agencies in the world, like Moody's and Standard & Poor's and others, which basically rate anything, right? They will rate financial instruments like this. They also will rate companies. They will rate banks. And they can rate the entire countries in terms of their economy prediction, right? But we want maybe build our own internal ratings of some bonds and securities that we want to be, essentially projecting to our own investors or something, right? So anyway, if we add a lot of financial information into the security and into the bond, and the rating engine can go directly and basically access a lot of information over here and over here in order to be able to provide this rating. Essentially, they're very closely coupled, very closely related. We say that these types of things should be indicated on the diagram as simply, right? Simply as these dependencies, right? We actually want to indicate the dependencies on our diagrams. That basically what dependency relationship indicates that a change, right? If there happens to be a change inside the security class, it's very likely that we also have to go and examine very closely the implementation of the rating engine in our rating engine in our application, and make sure that at least make sure that it still does what it's supposed to do, okay? Because very likely that a change that takes place inside the security or a bond class implementation will be affecting the implementation of the rating engine. Because the rating engine, when it works and does computation, it goes so deeply into the data attributes of the securities and bonds and histories of them, and types of them and everything else, that it essentially requires also changes if any of these classes do change. So this is just dependency is sort of like probably an unwanted type of relationship that you need to have, and that's why it's using the punctured line, not a solid line. It's like a necessity that we have because of the complexity of our application. Right? So this is a good question, but again, if you think about cause and effect, right, it's all about dependency, so you're absolutely right. It really does fall into this category.
Okay.
It does.
So the arrow will be on the dashed line towards the bond and the security.
Yes, it may be either way, but yes, you can essentially direct it a certain way and say, well, I guess if I do add arrow here, for instance, from the rating engine to the bond class, then I say perhaps what it indicates to me that the rating engine depends on the internal implementation of the bond class, right? So that's exactly how you would pronounce it and how you would understand it, right? Whereas then the opposite, it may not be true, because if we are making change inside the rating engine, that does not necessarily affect the internal implementation of the bond class. So yes, these arrows here would indicate who depends on who, right? So yes, great. This is definitely very relevant to what we discuss here in terms of relationship. And yes, cause and effect really do affect the how much dependency we have in our application.